In this video, we will tackle subjects that remain relevant then, now, and in the future. We will realize that a lot of things we enjoy today are reliant on our ability to maintain proper conditions that enable us to even dream of our future and pursue them accordingly. Most of our discussions would revolve on the importance of health, wellness, and aesthetics, things that many people consider blessings and treasures, which is only right because without these three things, imagine what life would be: a life with more hardships, boredom, and impediments than what we would have to face under a relatively better world. We will also realize how each one of us has a role to play in making the world healthier, and that the major health improvements that we see today came from the hard work of people with one main goal: to make the world worth living in. And lastly, we will touch on some issues that confront the health sector and how they call people to stand up to the challenge of solving them.
A brief history of scientific advancements in health. Whether it's the technology that allows us to peer deep into the body or medicines that extend the lives of those with chronic diseases, it's easy to see how advances in health and medicine have touched the lives of nearly every person on the planet. 1796. Vaccines. Throughout history, communicable diseases have had a tremendous impact on human history. And so, one of the most effective ways to defend against rampant viral infection has been developed: vaccination. It is difficult to pinpoint when vaccines became an accepted practice, mostly because the journey to discovery was long and complicated. But in 1797, a man named Edward Jenner, born in 1749 in Berkeley, United Kingdom, began to use inoculations to tame the infamous smallpox virus. He got the idea from a dairy maid who had a cowpox. You see, cowpox and smallpox viruses are from the same family, but when a virus infects an unfamiliar host, in this case, cowpox infecting a human, it is less harmful. So he decided to test whether cowpox virus could be used to protect against smallpox. Fortunately, it was a success. And so, the usefulness and popularity of vaccines grew very quickly. Throughout the 1800s and early 1900s, various vaccinations were created to combat some of the world's deadliest diseases, including smallpox, rabies, and cholera. Over the course of 200 years, one of the deadliest diseases known to man, the smallpox, was wiped off the face of the earth. Today, vaccines continue to save millions of lives each year. 1846. Anesthesia. Before the use of a general anesthetic in the mid-19th century, surgery was undertaken only as a last resort, with several patients opting for death rather than enduring the excruciating ordeal. Although there were countless earlier experiments with anesthesia dating as far back to 4000 BC, William Morton made history in 1846 when he successfully used ether as an anesthetic during surgery. Soon after, a faster-acting substance called chloroform became widely used, but was considered high risk after several fatalities were reported. Over the 150 years since, safer anesthetics have been developed, allowing millions of life-saving, painless operations to take place. 1861. Germ theory. Before the germ theory came about, the widely believed theory was that disease was caused by spontaneous generation. In other words, physicians at the time thought that disease could appear out of thin air, rather than being airborne or transferred via skin-to-skin contact. In 1861, French microbiologist Louis Pasteur proved through a simple experiment that infectious disease was a result of an invasion of specific microscopic organisms, also known as pathogens, into living hosts. This new understanding marked a significant turning point in how diseases were treated, controlled, and prevented, helping to prevent devastating epidemics that were responsible for thousands of deaths every year, such as the plague, dysentery, and typhoid fever. 1895. Medical imaging. The first medical imaging machines were X-rays. The X-ray, a form of electromagnetic radiation, was accidentally invented in 1895 by German physicist Wilhelm Conrad Röntgen when experimenting with electrical currents through glass cathode ray tubes. The discovery transformed medicine overnight, and by the following year, Glasgow Hospital opened the world's very first radiology department. Although originally discovered many years before, ultrasound began being used for medical diagnosis in 1955. This medical imaging device uses high-frequency sound waves to create a digital image and was no less than groundbreaking in terms of detecting prenatal conditions and other pelvic and abdominal abnormalities. In 1967, the computed tomography scanner was created, which uses X-ray detectors and computers to diagnose many different types of disease and has become a fundamental diagnostic tool in modern medicine. The next major medical imaging technology was discovered in 1973, when Paul Lauterbur produced the first magnetic resonance image, or also known as MRI. The nuclear magnetic resonance data creates detailed images within the body and is a crucial tool in detecting life-threatening conditions, including tumors, cysts, damage to brain and spinal cord, and some heart and liver problems. 1928. Penicillin. As with vaccination, the advent of antibiotics hailed a new era in the treatment of communicable disease. Antibiotics are compounds produced by bacteria and fungi which are capable of killing or inhibiting microbial species. But it wasn't until 1928 that Alexander Fleming, a Scottish biologist, accidentally discovered the antibacterial mold in a petri dish. He left the petri dish of Staphylococcus bacteria uncovered and later noted that the bacteria had been killed by a mold. Upon further studying the mold, he discovered it was from a family called Penicillium notatum. Others soon saw the potential uses of what later came to be known as penicillin. Penicillin, the world's first antibiotic, completely revolutionized the war against deadly bacteria. However, Fleming's incredible findings were not properly recognized until the 1940s, when they began being mass-produced by American drug companies for use in World War II. Two other scientists were responsible for the mass distribution of penicillin: Australian Howard Florey and Nazi German refugee Ernst Chain. Their development of the substance ended up saving millions of future lives. Unfortunately, over the years, certain bacteria have become increasingly resistant to antibiotics, leading to a worldwide crisis that calls for pharmaceutical industry to develop new antibacterial treatments as soon as possible. 1954. Organ transplants. Few surgical interventions today carry as much complexity or as much ethical significance as organ transplantation. In December 1954, the first successful kidney transplant was carried out by Dr. Joseph Murray and Dr. David Hume in Boston, USA. Despite many previous attempts in history, this was the first instance where the recipient of an organ transplant survived the operation. The turning point came when various technical issues were overcome, such as the connection between two blood vessels, placement of the kidney, and immune response. In 1963, the first lung transplant was carried out, followed by a pancreas or kidney in 1966 and liver and heart in 1967. Aside from saving thousands of lives in the years following, transplant procedures have also become increasingly innovative and complex, with doctors successfully completing the first hand transplant in 1998 and full-face transplant in 2010. 1960s antiviral drugs. Terrible viruses such as smallpox, influenza, and hepatitis have ravaged many human populations throughout history. Unlike the sweeping success of antibiotics in the late 1930s and 1940s, the development of antivirals did not really take off until the 1960s. This was mostly due to the structure of a virus, which was a core of genetic material surrounded by a protective protein coat that hides and reproduces inside of a person's cells. As the virus information is so protected, it was difficult to treat them without damaging the host cell. Over the years, antivirals have improved significantly. They work by blocking the rapid reproduction of viral infections, and some can even stimulate the immune system to attack the virus. The development of effective antivirals has been significant in treating and controlling the spread of deadly virus outbreaks such as HIV, Ebola, and rabies. 1970s stem cell therapy. The incredible potential of stem cells was discovered in the late 1970s when they were found inside a human cord blood. Two specific characteristics make stem cells remarkable. They are unspecialized cells that can renew themselves through cell division even after being inactive, and under certain conditions can be used to make any type of human cell. This discovery has enormous potential, and stem cell therapy has already been used to treat leukemia and other blood disorders. Research is currently ongoing to use stem cells to treat spinal cord injuries and a number of neurological conditions such as Alzheimer's, Parkinson's, and strokes. However, due to the ethical issues surrounding the use of embryonic stem cells, researchers are likely to face many obstacles when developing stem cell-based therapy. 1970s immunotherapy. Immunotherapy, a treatment that stimulates the immune system to fight off a disease, has been in the making for over a century. The story began in the 1890s with the experimental work of William Coley, who injected inactive bacteria in cancerous tumors, achieving remissions in some patients. However, it is only in the last 40 years that serious progress has been made in immunotherapy, particularly in respect to treating cancer. In the 1970s, antibody therapies were developed. In 1991, researchers produced the first cancer vaccine, which was approved by the FDA in 2010. In the last decade, immuno-oncology has become one of the most revolutionary cancer therapies in existence. 21st century artificial intelligence. Having been in gradual development over the past decade, artificial intelligence has already produced impressive technologies that have significantly altered the healthcare landscape. Life science companies and research institutions are teaming up with pioneer technology giants such as Google, IBM, and Apple to invent smarter and faster ways to diagnose, treat, and prevent diseases. These innovative technologies range from diagnostic tools that can detect malignant tumors invisible to the naked eye to cognitive computing systems that produce tailored treatment plans for cancer patients. Never before, science had so many applications to public health and medicine. Considering the progress that has been made in years past, it is tempting to view the state of health and medicine today as an endpoint, but this is just the beginning.
For the third part of the health section of this video, we are going to discuss some of the most notable advancements in the medical practice. First is the digitalization of health records. The major innovations in today's healthcare system wouldn't have been possible without the intricate web of information sharing among medical personnel. It enabled health practitioners to obtain relevant patient history and form a diagnosis at the soonest possible time without the impediment of a sluggish hospital records retrieval system. In the 1970s, the world saw the first installment of an electronic health record system when the Regan Strip Institute in the Indianapolis enlisted the help of Clement MacDonald to develop the system. Now, let's talk about public health and its improvements throughout the years. As societies become larger, people realized that the health of the entire community depends on the health of all of its individual members. Much of the health issues that we face today can never be solved without making sure that everyone has equal access to certain measures that ascertain good health at a societal level. And that's where public health comes in. What is public health? Charles Edward A. Winslow, a public health expert and bacteriologist, defined public health as the science and art of preventing disease, prolonging life, and promoting physical health and efficiency through organized community efforts for the sanitation of the environment, the control of community infections, the education of the individual in principles of personal hygiene, the organization of medical and nursing service for the early diagnosis and preventive treatment of disease, and the development of the social machinery which will ensure to every individual in the community a standard of living adequate for the maintenance of health. Let us take a look at the public health ideas and inventions that shaped the world today. 1546, Girolamo Fracastoro essentially proposed the germ theory of disease more than 300 years before Louis Pasteur and Robert Koch formally articulated it. According to him, each disease was caused by a different type of disease seed, now known as germs, and that it could be transmitted through air, direct contact, or from contaminated objects. 1662, John Grant summarized the data from the bills of mortality. By analyzing the data from the publication, he made significant discoveries regarding the common causes of death, higher death rates in men, seasonal variation in death rates, and the fact that some diseases have relatively constant death rates. He also made estimations on population size and rates of population growth. 1670s, Anthony van Leeuwenhoek was able to make lenses with magnifications of up to 270 times diameters and used them to create the first useful microscope. Using his invention, he was able to see bacteria, yeast, protozoa, sperm cells, and red blood cells. Fast forward to the Industrial Revolution, the explosion of development meant the expansion of population, and the growth of cities entailed mass migration. Poor families were often cramped in grossly inadequate spaces, thus making them more vulnerable to the spread of diseases. Workers were also exposed to work-related risks and dangers due to lack of regulations then. 1849, John Snow, the father of epidemiology, discovered that the source of cholera was contaminated water. He also excellently drew a map of the places where infection was prevalent, thereby pinpointing the exact areas where the disease formed an epicenter. With the map, he discovered that the main source of the cholera was the water being released by the Broad Street pump. This technique of mapping infection is still being used today by epidemiologists and public health experts. Some of the major achievements in public health during the 20th century were vaccination, eradication of smallpox, improved motor vehicle safety, safer workplaces, control of infectious diseases, decline in death from cardiovascular disease, improvement in maternal and child health, family planning, fluoridation of water, and reductions in prevalence of tobacco use. For this part, let us talk about nanotechnology. Nanotechnology is hailed as having the potential to increase the efficiency of energy consumption, help clean the environment, and solve major health problems. It is said to be able to massively increase manufacturing production at significantly reduced costs. Products of nanotechnology will be smaller, cheaper, lighter, yet more functional and require less energy and fewer raw materials to manufacture, claim nanotech advocates. Nanotechnology's contributions to society may appear small at the moment, but with the continued manpower and funding, it is hoped it will provide results and innovation. If nanotechnology continues to grow at its current rate, it will touch the life of nearly everyone on the planet in the next few years. Results of investigations and developments in nanotechnological fields are entering into all areas of our lives, such as agriculture, aerospace, energy, defense, material science, environmental science, and medicine. Next, let's talk about brain-machine interfaces. Brain-machine interfaces, or BMIs, combine methods, approaches, and concepts derived from neurophysiology, computer science, and engineering in an effort to establish real-time bidirectional links between living brains and artificial actuators. All the theoretical propositions and some proofs of concept experiments on directly linking the brains with the machines date back to the early 1960s. BMI research only took off in earnest at the end of 1990s when this approach became intimately linked to new neurophysiological methods for sampling large-scale brain activity. The classic goals of BMIs are, first, to unveil and utilize principles of operation and plastic properties of the distributed and dynamic circuits of the brain, and second, to create new therapies to restore mobility and sensations to severely disabled patients. Over the past decade, a wide range of BMI applications have emerged, which considerably expanded these original goals. BMI studies have shown neural control over the movements of robotic and virtual actuators that enact both upper and lower limb functions. Furthermore, BMIs have also incorporated ways to deliver sensory feedback generated from external actuators back to the brain. For the fourth part of the health section of this video, we are going to discuss some of the major issues of new technologies in health. First is security. One of the major issues of new technologies in health is security. It is a primary concern in healthcare applications since they often deal with confidential and sensitive patient health data. The healthcare industry has very stringent requirements around cryptographic security that dictates how and when the data needs to be encrypted, transmitted, and decrypted. To build a compliant telehealth application, specific encryption algorithms and data security standards need to be followed. Additionally, any underlying third-party platform used to power telehealth service needs to be completely secure with comprehensive data protection, access control, business continuity rules, and procedures in place. Second is data privacy and regulations. Another example of an issue is data privacy and regulations. There are a number of privacy laws and regulations that surround patient document rights, in particular, how providers share information. Inevitably, such regulatory measures put a burden on data fluidity and make it more difficult to adopt new technologies that involve data. Third is simple user experience. Undeniably, user experience is of utmost importance when organizations are considering changing or adding new technology or working methods. Survey results show that only 1 in 6 doctors use electronic health record systems regularly, despite there being incentives and bonuses attached to its usage. This suggests that many healthcare professionals are reluctant to change their existing methods and systems that they're accustomed to. The value of new technologies need to be quickly justified and proven to increase efficiency and customer satisfaction. Much like clinicians, doctors, and nurses, patients have tended to be slow adopters of new healthcare services as well. In order for the medical community and their patients to use it, the technology needs to be user-friendly and fit seamlessly into familiar workflows. Fourth is high-performing and high-quality solutions. Application performance and quality of service are essential for launching real-time communication solutions for the healthcare industry. More importantly, applications need to be available on the endpoints and devices that healthcare professionals and patients use on a regular basis. In an increasingly mobile-centric world, that means contending with issues related to Wi-Fi, 3G or 4G connections. Whether it's connectivity failures or a low bandwidth device, the communication service needs to be optimized to work reliably across a wide range of network conditions and environments.